We're going to begin the next part of the tutorial. In this tutorial, we're going to be importing a geometry that was generated from Cell Organizer, and we're going to import it into the cell with two organelles model that we had constructed on Monday, and we're going to replace the cell and the two organelles with the new geometry that came from Cell Organizer, and kind of do a crazy kind of presto changeo switch out of that geometry. So to start with, you'll need to download that geometry. So after this tutorial, you'll learn from Yvonne how how that was done, how to do that in Cell Organizer. But to motivate why you would want to do that, we're going to work with a geometry that was already generated and put it into Cell Blender and run the model in MCell. Okay, so to start, you'll need to download that geometry. So if you go to the Cell Modeling Workshop 2017 webpage, which is mmbios.org/CMW2017, and scroll to the bottom of that page, there'll be a link for data sets, and there's one there called Cell Organizer Example. And if you click on that, you'll get 3 different objects. So, download those to your machine. So it'll probably go into the downloads area, I guess, when you do a download. Download each one of those. And let me know if you're having trouble doing that. And maybe raise your hand when you've got it done, so I can see who's got it. Anyone still downloading it? Everyone good? Okay. So now from a terminal window, start up your Blender and you might see something like this. You might see exactly this, but but if you've just loaded it, your version hasn't been run before. So go to the Run Simulation tab. So hit the upgrade.
It'll disappear for a second, and then when you run the simulation and reload the visualization, it should work.
And after you do that, your molecules might disappear, and you'll just see the spheres, right? That's because it hasn't been run. Hit Run Simulation. So I'm going to hit Run again.
Yeah, actually, how you do it twice.
And you'll see a % completed as it runs. And Tara, later I'll explain to you what's going on in the model, because you haven't seen how it was built. But
I can too.
Oh, right. Okay, and now it's at 100%. So in order to see, you have to hit Reload Viz Data. And do you see any molecules? And if you don't see molecules lit up, if I go back to time 0. If your molecules aren't lit up, do you see molecules, Tara? No. So go to the Molecules panel, and over on the right-hand side of the Molecules panel, there'll be an eyeball. If you click on the eyeball, the molecule should appear. On the right-hand side of the Molecules panel is.
Okay.
And you see them? Okay, good. And then, just for Tara, if on the very bottom of the screen is the timeline, and there's a green line. If you grab that and drag it, then you're moving forward in time. okay? And if you go to the plot output settings and go to the bottom and hit plot, on my machine, the plot goes behind, but your plot probably comes to the front, and you should see up graphs with all your data. This is just a quick recap of where we left off on Monday, making sure that our models are still working properly before we do the next thing. Okay? Do you see that, Tara?
I didn't get the plot output setting.
It's the plot output settings panel right here. Yeah. And near the bottom of that panel is a plot button.
Got it.
You got the plot?
Got it.
Okay, good. All right, so now what we're going to do is, so that we don't mess up this model, let's do a save as and change the name of the model, because now we're going to make a new version of the model. And I'm going to call it Demo 3. Why not? And say save as. And then go back to your model objects. And one at a time. So if I click on each of these that lets me select a different model object. I'm going to click on the cell, and I'm going to say minus and delete it. We're going to delete our model objects that we spent so much time making.
Okay.
And organelle 1 we're going to delete, and organelle 2 I'm going to delete it. Now that just deleted it from the model objects list. It didn't actually delete it from the world. So now I'm going to put my mouse in the 3D view window, and then use the A key on the keyboard to make sure everything's selected. If you have stuff selected, you hit A, it unselects everything. You hit A again, it selects everything. Selects everything except the molecules, because the molecules are by default unselectable, so you don't actually accidentally mess them up. And now I'm going to hit X to delete everything. And all that remains are these little black dots, which are the locations of where the molecules were. And then in the molecules, and then but the glyphs got deleted. And then under the molecules panel, I'm just going to say hide all that to make the black dots go away. Okay, so now we have an empty model, except you'll notice that the names of all our molecules are here, and all their properties are still listed. And under reactions, we have all our reactions. And our molecule placement things are all good, except it says undefined cell organelle 1, right? Because we deleted those, right? So don't worry about any of that. Let's go back to the model objects panel.
So why do we?
So we've deleted all the geometry in our world, but not the biochemistry of the world, right?
I have to release type 4, which is linked to organelle 2, is still fine.
Well, say what?
Then it says undefined and equal object for the cells for organelle 1 play, but then for organelle 2, I've still got a valid release type.
Huh? I'm not sure why, but don't worry about it, because this is an intermediate state of the model. Okay, so now, yeah. So don't worry about it. It just means our error checking isn't quite robust. Now in the model objects panel, make sure your cursor is centered by clicking on the little plus guy over there to center the cursor. That's this little control right here. And now we're going to go to File, Import, Wavefront OBJ. File, Import, Wavefront OBJ. So Cell Organizer, when it generates a 3D shape for an object, for a cell membrane object, it's in Wavefront OBJ format. .obj is the file format. And then navigate to the location of where your OBJ files are. Maybe that's your downloads area. Does everyone see their OBJ files? And now, before we download any of those, in the lower left-hand corner of the screen are some settings for how the import's going to be done. And the default settings aren't really correct for our purposes. So you're going to turn off smooth groups and lines. You're going to instead of split, you're going to say keep vertex order.
What are the significance of these parameters?
They have everything to do with CG objects for computer animators for Hollywood, and the kinds of objects they make. But they don't. But our object is just a single object, and we don't care what material it's made from, and it's not made of lots of different materials and pieces that fit together. It's just a single thing, so we can turn those off. It'll try to do that for us when it imported it, and it does the wrong thing with this object, so that's why we turn it off.
You don't want them to try to smooth the groups.
Right.
And
Right. You can read online all about OBJ format for CG, but it's not for us today. And then, but the most important thing at the very bottom is how to set the coordinate system. So in Hollywood, for computer animators, they used to have a reasonable coordinate system that they all liked, but then something happened in the industry and they all switched to a different coordinate system. We're going to switch to a forward minus y. Or, so choose your forward setting should be minus y forward, and that will automatically set the up vector to z up. So this is a right-handed coordinate system in which the x and y coordinate system is on the floor with positive x going to the right and positive y going away from us, or minus y coming toward us, right? And then the z vector is up, so that's height. Above the floor is z. So this is a standard, physics right-handed coordinate system that's more reasonable for our purposes. Okay. And then you can turn off the image search because the OBJ file might have images that are texture mapped onto it. If you're making the Rocky Mountain chain, you might want to have snow-capped mountains, but that's not what we're doing. Okay, so now you're ready to select the first one, which is the cell.obj. Go over and say import obj. And that thinks for a second. And then there's our object. And it's a huge object because it's in a different system of units that came from Cell Organizer. We're going to fix the units as we work with the object. Yeah? Oh.
yeah.
Oh wait, the error disappeared, but there's still not.
Oh.
Did you try doing it again?
What was the error?
Something about the file location.
Okay, so do it again. Import obj. Cell. Yeah. That should have remembered that, but it didn't. Y minus y forward. Yeah. And cell.obj. And import. And now it's. I'm not sure. Yeah. Okay. That's.
Okay.
Wait. You might see. Okay. Okay. If you've got that working, let's change our, let's see, how do we do that? I think it's Shift-C. Yeah, on your keyboard with your mouse positioned in the view window, hit Shift-C, capital C. And that will zoom out and center our object in the world. Okay, and Now if you right-click on the object, you'll see that it's already called cell. It inherited its name from the file that it's located in. And the file name was generated automatically by Cell Organizer. And after you've imported it and verified that it has the name that you like, cell is what we want to call it, hit the plus button. So let's, in your File Open menu, say Open Recent, File Open Recent, open your previous version of the file.
Demo 2.
Yeah, Demo 2, if that's what you called it.
Why not number 3?
Because, just listen to me. Trust. We deleted things the wrong way, and there's a bug that we'll have to fix. But I think I know what I did differently.
But I didn't delete anything yet.
You didn't do it earlier and have it work, and I did. So under your molecules, hide all your molecules.
All right, quickly before we do that, we still want to upgrade this blend file to current version, correct? When we reopen the CMW,
Yeah.
we're still
Yeah.
Okay.
Yeah.
All right, just making sure.
Yeah. Okay. And I'm hiding all my molecules. And now I'm going to go back to the Model Objects panel, and I'm going to delete each of the model objects one at a time. And then I'm going to select all my model objects with the A key. Or, select all my visible objects in the world with the A key. I'm going to hit X. I'm going to hit X and delete. Now I'm going to do save as, and save it as demo 3. Okay. And now we're going to import. File, import, wavefront OBJ. Choose the cell. Make sure you turn off smooth groups and lines and keep vertex order and the image search and -Y forward. And then say import OBJ. Uh-oh.
So what was the difference there? I don't.
No, it it didn't import.
Pick up this and make that
Oh, wait. Hold on a second. I'm not sure why it's doing that. I'm turning off all that monkey business again. Don't know why it failed the first time. Change in the model objects. Let's see.
So
Right.
it works this time, right?
I think it's going to work. Right-click on the object to select the object. Its name should appear above the model objects. Make sure it's called cell. Add it as a model object. There it is.
Yeah. So the difference is this time
So-
you delete the molecule.
Yeah, we didn't delete the molecule glyphs accidentally and make all those black points.
Yeah.
Yeah, I think that's what it didn't like. So that's our bug. We'll fix it. Okay. Okay, so now let's hide. So if with the cell object selected, hit the H key on the keyboard, and that will hide it. And now let's go and import wavefront OBJ. The next object is going to be the nucleus.obj. Since the previous import was successful, these settings down here are retained. But verify that they look correct, and then say import OBJ, and then there's our nucleus. And right-click on it to select it, and its name will appear as the active object, and then it's called nucleus, but we want this one to be called organelle1. So before you add it as a model object, say organelle1, and then hit plus to add it as a model object. You can hide it, but let's keep it visible.
Where did you change? Oh,
I changed it to, it's named organelle1, right here.
changed it there.
Yeah. And I'm going to do a save, just for good measure. Save early, save often. Okay. And now I'm going to do a file import wavefront OBJ, and I'm going to choose Endosome 1. So the names, like I said before, the names of these objects were created, named automatically by Cell Organizer. But our original model that we made, we called them organelle 1 and organelle 2, and our whole model is kind of constructed based on that, so that's why we're renaming them after we import them.
How did you get the cell to go back to the right side?
Oh, it's hidden back here. Yeah,
Oh, Shift C.
You didn't see it?
Did that work? Okay. Okay, so I imported the endosome, and it's this little guy over there. And so right-click on it to select it. And its name, again, appears above the model objects list. Change its name from Endosome 1 to organelle 2. And then add it as a model object by hitting the plus button. Okay. So now we have our 3 objects imported but they're from an unknown source, and they're of unknown quality, for an unknown suitability for modeling with. These were actually created last year, or maybe even 2 years ago now. 2 years ago. And at that time, the mesh generation, surface mesh generation function being used by Cell Organizer wasn't quite as good as what they have now. So these models actually have some flaws that we will repair.
Also, I want to say that in Galaxy, we have mesh analyzer. So after you generate your OBJ file, you can get an assessment of the quality of the OBJ, which we couldn't before.
Yeah. So some of the things that we're going to do right now by hand will be done automatically by Cell Organizer. But it's a good thing to learn. And some of the things that we're going to do, you will need to do regardless. Right? So first of all, let's right-click on now it's called organelle 2, or you can click on its name in the model object list. And then up above the Cell Blender panel is another panel that's currently hidden called the Cell Blender Mesh Analysis panel. You can click on its little triangle, and that will expand it. Okay. So now we're going to be doing a few things that are new that you haven't seen before. We may have looked at this briefly on Monday. If you click on Analyze Mesh, it gives us an analysis of this mesh.
Of the endosome.
Well, it should be called organelle 2 now.
Right.
Yeah. Yeah. Organelle 2.
I can select it in the model objects.
Yeah. You can click on its name in the model objects list. and then do analyze mesh. And you'll see it's got 40 vertices, 114 edges, 76 faces. It's got a surface area volume. But the more important thing are the items at the bottom of the list listed under mesh topology. It says it's watertight, it's manifold, it's got inward-facing normals, one component, genus 0. So that's all good except for the inward-facing normals part.
Okay.
Remember on Monday we said we want objects to have outward-facing normals. So if now, let's see, Shift S. Oh, wait, Shift C. With the endosome, selected and highlighted, under the View menu, say View Selected. And that will zoom in and make that object be. Did you find that, Joseph? The view menu of the 3D view window, not the view menu of the timeline. Right. So do you see that, Tara? Did you get that? Okay. So there's our mesh. Under the Model Objects panel, we don't have to worry about that this instant. So under the Model Objects panel, there's Organelle 2 object options. And one thing that can be helpful in assessing the quality of a mesh is to click on Show Wire, and that'll put up a wireframe on the object. And if you kind of spin the object around, you can see most of the triangles look like they've got what's called a good aspect ratio, which means they're close to being equilateral triangles, not too far off from being equilateral triangles. Except for one or two, not a big deal. So we don't have to worry too much about that. But the thing we have to worry about is the fact that there's inward-facing normals. So to fix the normals, with this object selected, you can tell it's selected because it's got the yellow highlighting. Hit the Tab key on the keyboard, and that will take you into edit mode. And in edit mode, there's 3 different types of editing you can do. You can edit vertices, you can edit the edges, and you can edit the faces. And it looks like we're in face editing mode, because in the middle of each face we have a little square dot, which is kind of the handle for the face. And that's just an indicator. Just to explain that, we'll be doing some more with that in a little bit. Now under the mesh, notice at the bottom of the 3D view window, it's now, instead of saying object mode, it now says edit mode. That's a drop-down menu that lets you switch to different modes. So if you don't know the hotkey, which is the Tab key, you can use that menu to switch. But right next to that is a menu called the Mesh menu now. If you click on the Mesh menu and look for the Normals menu option and hover over it, you'll get a side menu that pops up, and we can say recalculate outside. So what that did was it automatically flipped the way the mesh is connected from left-handed to right-handed to make all the vertex surface normals or triangle normals point outward. Yeah.
So I think so. In everybody's mesh, there's one face that looks different than the rest.
Yeah.
What's the deal with that one?
Oh, it's just a different shape.
No. I mean, it's a different color.
A different color?
It's gray, whereas the other ones are orange.
Yeah.
Oh, so that's probably face number 0. It's got a stippling on it, What that means is that's if you were to do something that operated on, it's showing you that's an indicator that tells you that that is the active face. If you were to do any operations that operated on only a single face, that's the one that would be affected. If you were to right-click on a different face, you would change what that was.
Okay.
And again, the A key toggles selection on and off of all the faces. So this is a really dangerous mode to be in, edit mode, because you have to really be careful with what you click on. As you know, dangerous, right? Dangerous for people who don't know what they're doing. Right now, you guys are newbies, but as you learn the tool more, and there's lots of this is a whole universe and whole world of things that you can do with the meshes. I'm showing you the basic things that you need to do with meshes that we want to do computational modeling with. And generally, you don't want to be messing with the faces in an artistic way. You want to be you want to be doing it in a very disciplined and principled way, right? Not that artists aren't disciplined. They're disciplined by their art, right? But here we're trying to do quantitative biology, and that's our art. Okay. Okay. So we've just flipped the normals. So now we can get out of edit mode by hitting the tab key that toggles between edit mode and object mode. And now under the mesh analysis, you can click on Analyze Mesh again, and now it says outward-facing normals. Also, if you'd been, I didn't point it out, but if you'd been paying attention, the volume was previously minus 1056.6, and now it's plus 1056.6.
So now we want to do that on the other object as well.
Yes, exactly. So now I'm going to zoom out, or you can go into the Model Objects panel and click on Organelle 1, and then say View Selected under the View menu again. You can say View Selected, and that will automatically switch over to that one, making it be our center of attention. And now with that one selected, go to the Mesh Analysis and hit Analyze Mesh. And under our mesh topology, again, it says watertight, manifold, inward-facing normals. So it's perfect except for the normals. And so now let's, like we did before, let's say show wire under the object options, underneath the Model Objects panel. Let's say show wire so we can see the wireframe of that one. So you can see the triangles on this one are kind of, well, if it looks, I don't know. There's all kinds of aesthetics here. There's all kinds of analysis that one can do on the shapes of the triangles to validate their quality for doing all kinds of different kinds of computational work. We're not going to talk about that much or cover that at all. But generally, if it looks ugly to your eye, or if it looks irregular and ugly to your eye, it will also be irregular and ugly to the math, to any math that you want to perform on it. So we'll worry about that in a minute. Right now, we're worried about the inward-facing normals. So again, click on the Tab key to go into edit mode, and then say Mesh, Normals, Recalculate Outside. And you'll see that the color kind of shifts on it, which is the surface normals are are part of what determine how the simulated light in Blender is interacting with the surface. And so we've just completely flipped what direction the normals face, so of course the color is going to look different. Don't worry about it. This will be resolved as we do more work on it. Okay, so now we're good. We can get out of edit mode and verify that We now have outward-facing normals in mesh analysis. It's now happy.
Yep.
Okay, and now let's go back to the Model Objects panel and click on Cell. And when you click on Cell, it automatically makes it visible again and selects it.
And that's not what not manifold.
Yeah, so now do your mesh analysis. This one is a problem child. Non-watertight.
And then also consistent manifolds.
And consistent normals.
Sorry, consistent normals. So
Consistent normals, even though it's not manifold. That's, it seems like that's got to be an anomaly of the normals calculation. It's just dumb luck that that's how it came out.
Okay.
It's just dumb luck. Well, and we're going to look at, and we're going to fix it right now. Right, the problems that this mesh has will become apparent in the coming steps. Okay, I'm not going to give you a clue yet what they are. Okay, so let's go into edit mode, and you can see this one has a lot of triangles in it. In fact, once you go into edit mode, by default with a newly imported object, it comes up with all the faces highlighted. And if you look up at the top of the screen, it'll tell you how many faces it's made of. It says 91,220 faces. That's a lot. Just just for fun, to let you know, the model that I showed you earlier today, in total, over all the dendrites and axons in the glial cell, in total that was about 4 million triangles altogether. And the glial cell alone had 1.4 million triangles in it.
Wow.
And just
But enough
and just for
data
fun,
to know if it had a volume.
just what's that?
You had, how do you know it was the same glial cell over the whole volume?
The same what?
Because
Oh.
of the reconstruction.
Oh, well, we know that it's the same cell. It was all connected. And also we know from very rigorous work from Eric Bouchon in Mark Ellisman's lab at UCSD. They did a very detailed analysis of astrocytic glial cells and found that single astrocytic glial cells extend into neural tissue a diameter of about 60 microns in all directions. And if you and have this and have that very fine filigree structure to it all throughout, except for where the soma is and the nucleus is. But outside of that, it just immediately does this thing. Okay, but that still doesn't tell us that it's one cell. They also determined by labeling multiple cells that the cells tile space with their own separate territories that overlap with each other only at the very fringes of the structure. So it's like a single astrocyte has staked out its own separate domain and has influence over all of the synapses and dendrites and axons within that domain. About 350,000 synapses are if the synapses have a density of about 1 per cubic micron or so, will be within that volume, 350,000 cubic microns of volume. So it's a good guess that it's one.
Yeah.
Plus it was all interconnected.
Yeah.
Yeah.
So if there are not really any interconnections between ones, then you're saying, yeah, if it's connected, it must be the same.
Yeah, exactly. So just for fun, I'm doing a quick rotation here just to show you the performance of the graphics cards that we have here. And I could do the same thing with the whole astrocyte and wing it around like I'm holding it in my hand. It's pretty amazing.
Yeah.
This was the performance that Art Wetzel was alluding to yesterday. Many teraflops of computing power in these little devices. Okay, So first of all, to find out where the non-manifold problem is coming from, because it says it was non-manifold, and it also says non-watertight. Those two things can kind of go hand in hand sometimes. We need to switch from face mode to vertex mode, and that's done with these buttons down here. I'm going to point to the screen here with my finger so you can see where it is, because so click on the leftmost of this triplet of controls. That puts us into vertex select mode, and if you hover over it, you can see it says vertex select. And the next one over is edge select, and then the last one, of course, was face select, right? So we're in vertex select mode. So in vertex select mode, now we can go to the select menu, and we're going to say select all by trait. Oh, wait, no, first of all, let's unselect everything by hitting the A key, and then this all goes black. And then I'm going to say select all by trait, non-manifold. So Blender will automatically find the non-manifold elements and select them for us.
6 of them.
And mine says 2 faces.
Yeah, 2 faces, 6 edges, and 6 lips.
Right. It's the 2 faces that we're interested in. And so now I'm going to rotate my object. Oh, it's at the top of the screen. It says there's two faces are now selected. So I'm going to rotate around here until I can see one. And where's the other one? There's another one somewhere. Where is it?
Are they not 2 connected faces?
They're not 2 connected faces. They're 2 disjoint faces.
Right, no,
Where's the other one?
maybe we'll find one
Oh,
there.
there's
Oh, no, there we go.
Oh, okay, I see them.
Yeah.
So, okay. So we're going to do some surgery on these 2 bad faces. It's not hard. So in order to help us in order to help us isolate those bad faces and find exactly which ones they are, we can see them there, but it's going to be hard to work with when they're connected to everything else. We are going to use a feature in the select menu called select more/less. And we're going to say select more. And the hotkey for it, I don't have this hotkey because I don't have a numeric keypad, but you guys do. You can hit the control key and then hit the plus. Hit control plus
Didn't you say there was an option to make it mimicking them?
to make them,
To make the laptop like mimic a numpad?
not a numpad, a 3-button mouse,
Yeah, okay.
but not a
Okay.
numpad.
Okay.
Yeah, but not a numpad, yeah. So I'm going to hit control. I'm going to hit select more once, and I'm going to do it again. So notice that when I say select more, what it's doing is it's expanding the selection to be the next most connected, the next nearest set of connected elements, right? So I get 2 little blobs. Okay. And now I'm going to hide everything except what's selected. To do that, you hit Shift-H on the keyboard.
Yeah.
And that made all that disappear. And now I'm going to unselect all.
Put your cursor into the
Yeah.
view.
Yeah.
And hit A. And then right click whatever you say.
And then I'm going to unselect everything, hit the A key to unselect everything. A key to unselect everything. And then we're going to zoom in on one of these groups. To do that, to make that easier, hit the B key, which is the border. It's called the border select key, and draw a little box around one of the groups, like that. and then say View Selected to zoom in on it. View, under the View menu, say View Selected. That zooms in on it. Oh. Okay. And then unselect all with the A key. And now say select all by trait non-manifold. Now we can see our one little thing highlighted there. And you might have to pivot around to see what's going on with it. But if you zoom in on it, keep zooming in on it. If you look at it from from just the right angle, you'll see that it's sticks out like a shark fin, like a little tiny shark fin, right? And you can see there's a vertex at the apex of the shark fin.
Is there an
Can you see this? I've got the problem spot isolated. There's the problem right there. We have this stray vertex sticking out from the surface. So if you now right-click on that vertex, it will highlight just that one vertex. Okay, so if everyone has right-clicked on the bad vertex, now you can hit X. Yes? Hit X. And then a menu pops up, and we're going to say delete vertices.
Okay.
And then it's gone. Yeah. Okay. And so now I'm going to zoom out and use the B key to select the other patch. And then say View Selected. And we have there's a similar problem on this one. I'm going to say, but I can't see which one it is, so I'm going to say Select Non-Manifold. There it is. There it is. And then find that one bad vertex, select it. Is everyone able to see that?
How are you telling that it's a bad vertex? Because it sticks out the surface. It's like not smooth with the rest of them.
Can you see it? Can you see it sticking out?
And then
If I really zoom in on it really close, you can see it sticking out. Right? So delete that one, X, delete vertices. It's gone. Okay, and then now zoom out so that you can see more of the scene. And now to bring everything back that we made invisible, you say Alt H. Hold down the Alt key or Option key. Alt H. Everything comes back.
wait.
Okay. And then say unselect all. And just to verify again, say select all by trait non-manifold. And now it says 0 selected. Zero vertices, faces, and edges. So now, since we did some surgery on the mesh, we may have changed some of the triangles to be non-triangular. In this case, we didn't, but just for good measure, we say select all with the A key, and then say mesh faces, triangulate faces, which is this menu item here.
So
Mesh,
you just select the
mesh faces, triangulate faces, but with everything selected.
even the other, or just
Also, I hit the A key to select all.
Yeah.
Okay? Say triangulate faces, and that just makes sure that everything is now really triangles. They probably were because we deleted things. We didn't add anything.
Triangulate faces.
Okay, and now hit Tab P to get out of. Oh, well, we also know that before we do that, we also know that the normals were facing. Well, it said consistent normals,
All right, yeah.
right?
How can I check again that the original
But they were
mesh-
probably inward. What's
How can I
that?
check again that the original mesh is watertight now?
We're gonna check it.
Oh, okay.
Yeah, we're gonna do that. We haven't done that yet.
Okay.
Yeah. Okay. So before we do the next thing, get out of edit mode. Hit the
Wait.
Tab key.
Triangulate faces, quad method beauty, polygon method beauty.
Just triangulate. Doesn't matter.
That didn't show up for me. The Rex, this stuff.
I don't know.
This mesh.
So hit Analyze Mesh,
Open up and like,
and now it says watertight manifold inward facing normals.
This is
Yeah.
muted.
Okay. So we have one last thing to do. We're gonna go back into edit mode and mesh normals. Recalculate outside. Get out of edit mode. Go back to Analyze Mesh.
if you just press edit, I'm like, mesh it switches back out of edit mode anyway.
It might. Yeah, maybe it will, maybe it won't. Okay, so now we have watertight. Okay, so I think we're going to need to switch back over to Yvonne, but we're going to do one last quick thing. Oh,
Can you show me something here?
what's that? Is it stuck?
I can't see the properly, and I need to, what is a key?
Shift C. Should recenter the world.
Yeah, now how do I zoom?
And then
Bigger.
now you need to pinch. You can use the trackpad to pinch.
Because my
Okay,
wheel
it is-
is.
Oh. So we're going to do one last quick thing. We're not going to be able to finish everything, but I want to show you one last quick thing that you should see. So now with the cell selected, the object called cell selected, by clicking on it in the Model Objects menu, over on the tab key of the tool shelf, all the way on the left-hand side, there's a tab called Gamer. Click on Gamer. Go into edit mode just for a moment to verify that everything is selected in the mesh by hitting the A key to make sure everything's selected. Because Gamer will operate on the entire mesh or on parts of the mesh. It'll operate on only the elements that you have selected. So it's really a powerful mesh tool.
Only the cell should be selected right now.
Yeah, only cell.
Press A, then everything.
Okay.
But yeah, if you press A,
But
then-
it doesn't select the inside guys.
Right, so let's go back and select
And then get out of edit mode. And then we're going to click on the Surface Mesh Improvement panel. Right? I mean the Surface Mesh Improvement control. Oh, just for a quick moment, switch back to the Cell Blender tab. And under the Cell Object Properties, under the Model Objects panel, click on Show Wire so that we can see the shapes of the triangles. And then switch back to the Gamer tab. And we're going to do two operations. The first operation we're going to do is called Smooth Tries. Click on Smooth Tries.
And there's an error.
Probably you don't have the object selected,
Yes, I do.
and maybe none of its mesh elements are selected. Go into edit mode. Make sure the whole thing is selected in edit mode.
No, see, mine says it's
Yeah, it's not selected.
Yeah, that'll do it.
So,
Has to be all selected.
select all,
and then go out, and then get out of edit mode.
How do we select the one edit mode?
Fractal beauty. Dig it. I dig it.
Just make sure all the elements are selected when you're in edit mode, and then exit from edit mode.
Oh, actually, I think they were selected. I just didn't have the wire on them.
How long is that going to take? Is that going to be just for that object mode? Is that
Yeah, we're only operating on one object. So the cell object.
right? So now back to
Should I come look at your screen? Should I come look at your screen? Are you in edit mode, or
Yep.
get out of edit mode?
Okay.
Oops.
Now I'm not in edit mode.
Okay, zoom out a little bit. Okay, now under mesh improvement, hit smooth tries. Now it's working.
Yeah, now it's
The plot out.
Okay.
See what the effect is on the
Ooh, now that's
diagram.
brilliant.
So after doing that, you should see
Tries versus the
that your triangles are much prettier, but there's still a lot of triangles, probably way more than we need. This is something that you would judge by eye by looking at it. And for this particular kind of mesh, which has a very smooth and regular topology, the radius of curvature is pretty much the same everywhere on this object. We can use the function called coarse dents. So what that does is it tries to decimate and remove triangles in areas where they're too dense. The net effect of this is over iterations, it will try to make all the triangles be about the same size. So it'll delete smaller triangles preferentially over larger triangles. This makes sense if the radius of curvature is very smooth over the object. If you have parts of the object that are have very small radius of curvature and other parts that are very flat, you want to use instead the function called coarse flat. That'll try to make bigger triangles in flat areas, but while keeping smaller triangles in tightly curved areas. So what it tries to do then is tries to sample the curvature of the surface at constant rate of curvature. Right? So we have two different operations. So under coarse dents, we're going to change the coarse dents rate to 4. Change that to 4, and change the number of iterations to 5. And then hit the coarse dense button, and you'll notice that it got denser. It got less dense. And I'm going to click it again, and it got even less. And I'm going to click it one more time. That looks pretty good. And then I'm going to hit smooth tries one last time. And now we have something that we can work with. And we would do the same operation to the nucleus. Previously the nucleus. The smallest one looked pretty good to start with, so we wouldn't do it to that one. And then we would, and since we've named everything the right way, we would be ready to run the simulation. But at this point, we're going to turn things back over to Yvonne so that he can continue and not take up more of his time. But as any of you who are around later this afternoon, we could finish this, or it's left as an exercise to the rest of you because you've already seen how to do it once.
Did it change the shape?
Do what?
At
Oh,
all,
just
the
the inside
roughness of
ones?
the bumps?
So this will this is a very sophisticated meshing algorithm. If you have other kinds of meshes that have sharp edges, you can click on Preserve Ridges, and it'll try to preserve those sharp areas as much as it can. And then there's this normal smooth function at the bottom, which tends to smooth out the surface without changing the volume of the object. But it will change the surface area because it's becoming more smooth, right? And that bumpiness is noise, might be noise in the surface. There's a little bit of an art and a science to this. The art part is, does it look as smooth as I would like? But the science part is it changing the volume of my object? And you can verify that by looking at Measurealizer and seeing how, under the mesh analysis tool, seeing if the volume is changing. You can also see it by eye, looking at it. But when something is pretty smooth, if you if you do the normal smooth again, you might notice that it grows a little bit. And that's telling you that it was already smooth enough. And you can hit Control-Z for undo. And you can always go, yeah, it's really cool to use this tool. You can go through several steps and then say undo, 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 and you can go back several steps and kind of see how it changes.
Yeah, so what's sort of the optimal smoothing? Are we doing this to make it computationally easier for simulations? Or?
Well, you're trying to get an accurate representation of the shape of the object, and some of that shape is noise.
Okay, right. You
And-
assume
and
it's
it-
imperfect that you generated
Right,
from the data.
right. And is it a feature or is it noise?
Yeah.
One person's noise and another person's feature?
Okay. So
Maybe,
you just have to
maybe.
sort of eyeball
Right.
it and get
You can eyeball it
Okay.
and do a pretty good job.
All right.
Okay. So that ends the instruction for that.